Hello students, till now we have seen that standard electrode potential for any element is considered as its standard reduction potential, or in other words, according to latest IUPAC convention, standard reduction potential itself is considered as standard electrode potential. Lower the value of standard reduction potential, then it will act as anode, oxidation will take place and it will act as a reducing agent. On the other hand, the element with higher the value of standard reduction potential, it will act as cathode, reduction will take place over here and it will act as oxidizing agent. By knowing the E0 values of cathode and anode, we can determine the overall potential of the cell. E0 cell equals to E0 cathode minus E0 anode. Remember, whenever we are writing the symbol of not, then it indicates the standard conditions. If we are simply writing E cell, that means the conditions are not standard. Now, based on the standard electrode potential of various elements, they are arranged in one particular series, and that is what we call as electrochemical series. In 10th class, you have studied this under the heading reactivity series. It is one and the same thing. So, in electrochemical series, we are arranging the various elements with respect to their standard reduction potential. So, what do you mean by electrochemical series? It is the arrangement of elements in order of increasing reducing strength. And this is the topic of our today's video. We will be discussing electrochemical series. We will be discussing its applications. So, what is an electrochemical series? It is the arrangement of elements in order of increasing reducing strength. On the top, we have fluorine with its SRP being plus 2.7 volt. Then in between, we have hydrogen which has SRP 0 volt, and at the bottom we have lithium with its SRP minus 3.05 volt. That means any element cannot have higher value than plus 2.87 volt, or it cannot have value less than minus 3.05 volt. There are many elements in this series. So many elements are there between fluorine and hydrogen. Many elements are there between hydrogen and lithium. But you need not to learn the whole series because the SRP values will be given in the question. Now if I discuss this electrochemical series, especially if I talk about the reducing strength. So if I move towards lithium, that means if I move towards the bottom of the series, then the reducing strength increases, indicating that lithium is the best reducing agent. It has the least SRP value. If we move towards fluorine, that is if we move towards the top of the series, the reverse thing happens. The oxidizing agent strength increases. That means if I look at the overall values of SRPs, fluorine, it will be best oxidizing agent. We know fluorine being the most electronegative element of the overall periodic table, it easily accepts the electron and itself gets reduced, therefore it acts as the best reducing agent. On the other hand, lithium, it easily loses the electron, itself gets oxidized and act as the best reducing agent. If I talk about the other characteristic of electrochemical series, when we move towards the lithium, when we move from top to bottom, one is a reducing agent strength increases, second is tendency to act as oxidizing agent will decrease. If you move towards top, it will increase. Thirdly, reactivity. Reactivity in terms of tendency to lose electron. Tendency to lose electron as we move towards lithium, it increases. Next, electropositive character increases. That is the metallic character increases. because we know fluorine being most electronegative element, it will not lose electron, it will gain electron. The tendency of elements to liberate hydrogen gas when treated with acid it also increases. That means the elements which are placed below hydrogen in electrochemical series, they will be able to liberate hydrogen gas when they are treated with acid. But the elements which are placed above hydrogen in electrochemical series, they will not be able to release the hydrogen gas. Generally speaking, the top elements, they act as good oxidizing agent, whereas the bottom elements, they act as good reducing agent. Now I can correlate this with their SRPs also. More the SRP, then it will be better oxidizing agent. There are many concepts that you can use in this topic and I am trying to give you all the concepts. Lower the SRP, then it will be better reducing agent. For example, you can see here lithium has very low standard reduction potential and therefore it is the best reducing agent. Fluorine has very high standard reduction potential and therefore it is acting better oxidizing agent. So the element with low SRP will itself get oxidized and will reduce other. The element with more SRP will itself get reduced but will oxidize other. Now why we are studying this electrochemical series? Electrochemical series has lots of applications. So let us discuss what are the applications of electrochemical series. The very first is predicting oxidizing and reducing agent. If we know the SRP values of elements, then we can easily find out by comparing which one is the best oxidizing agent and which one is the best reducing agent. We now know that if SRP value is high, then it will be best oxidizing agent, and if SRP value is low, then it will act as best reducing agent. For example, we know E0 of fluorine is minus 2.87 volt and E0 of lithium is minus 3.05 volt. So fluorine has more standard reduction potential and therefore it will act as a better oxidizing agent. Lithium having low standard reduction potential, it will act as better reducing agent. So by comparing the SRP values, we can predict the strength, or we can predict which one will act as oxidizing agent, which will act as a reducing agent. By using the same concept, we can compare the oxidizing and reduction tendencies of the elements. For example, SRP of zinc is minus 0.76 volt and that of copper is plus 0.34 volt. So if I compare these two elements, which one has low SRP? Zinc, and therefore zinc will act as the reducing agent and copper will act as oxidizing agent. So if I want to construct a half cell using zinc and copper, zinc is acting as reducing agent, so it will itself get oxidized and therefore it will act as anode, whereas copper will act as cathode. I will take one more example. I want to construct a cell using zinc and iron. So let us have a value of SRP of iron. It is minus 0.44 volt. Now if I compare both these values, obviously again zinc has a higher value, zinc has low value of SRP and therefore it will act as reducing agent, whereas iron will not be comparatively, it will not be that much good reducing agent, it will act as cathode. Now the next application is to predict the feasibility of reaction. Once we are able to identify the cathode and anode, we can find out the EMF or cell potential by formula E cathode minus E anode. Now how does it helps us to predict the feasibility? If the value of EMF is positive, then we can say the reaction is possible, the reaction is feasible. On the other hand, if the value of EMF is either 0 or negative, then we'll say the reaction is not feasible. So I can give a hint over here, or I can have a guess over here. The anode SRP, it must be highly negative. If anode SRP it is negative, obviously EMF will be positive, reaction will be feasible. Or we can say E cathode should be always greater than E anode so that the reaction is possible. For example, if we consider the Daniell cell, we know Daniell cell is made up of zinc and copper. So if I take zinc as anode and copper as cathode in Daniell cell, we know all these things. So EMF will be equal to E naught cathode minus E naught anode. The value of cathode, which is copper, is plus 0.34 minus anode, which is a zinc, minus 0.76, that is equal to 1.10. The value comes in plus, and therefore we say the E naught of Daniell cell, since it is positive, the reaction between zinc and copper is possible. The same thing we can have in another way, like electrochemical series is used to predict the spontaneity of a reaction. Let us consider the reaction zinc plus H2SO4 giving ZnSO4 plus hydrogen gas is liberated. Now let us say whether the reaction is spontaneous or no. Zinc from 0 oxidation state is getting converted to plus 2 oxidation state. That means there is oxidation of zinc. Okay, since it is oxidation, now let us find out for hydrogen. In H2SO4, hydrogen is in plus 1 oxidation state. From here, it is getting reduced to 0. So here there is a reduction. We know if oxidation is taking place, that means zinc must act as anode, and if the reduction is taking place, that means hydrogen must act as cathode. According to electrochemical series, zinc is placed below hydrogen, and therefore this is possible. So we have to remember this concept. Cathode should be placed above anode in electrochemical series. Now according to electrochemical series, this combination is possible, and therefore we will say this reaction is a spontaneous one. Let us have one more example. Copper plus HCl giving CuCl2 plus hydrogen. Now here again copper from 0 oxidation state is getting to plus 2 oxidation state. So this is oxidation. Okay. And hydrogen, it is in 0 oxidation state. From 0 it is getting converted, this is plus 1 oxidation state for hydrogen, and from that it is getting reduced to 0. So reduction is taking place, but in electrochemical series copper is placed above hydrogen. So according to given reaction, hydrogen is acting as cathode and copper is acting as anode, but actually reverse has to be there. Cathode should be placed above anode in electrochemical series, and therefore this reaction is non-spontaneous. This combination will not be possible. Electrochemical series also helps us to identify whether a given metal will react with acid to liberate hydrogen gas. For this, I will give you one concept, that all those electrodes or all those elements with negative E naught value, with negative SRP, they will liberate hydrogen gas when the metal is treated with acid. On the other hand, element with positive E naught value will not liberate hydrogen gas. For example, when zinc is treated with HCl, we get ZnCl2 plus hydrogen. Okay, here zinc is getting oxidized, hydrogen is getting reduced. Since zinc is getting oxidized, it will act as anode. Since hydrogen is getting reduced, it will act as cathode. Now let us have a look for E naught value. E naught value of zinc is minus 0.76 volt. Now since the SRP of zinc is negative, it will be able to liberate hydrogen gas and therefore this reaction will be possible. I will consider this reaction again. Copper plus HCl giving CuCl2 plus hydrogen. We know the SRP value of copper. It is plus 0.34 volt. And since the E naught value is in plus, this reaction is not possible. So if the question is asked in the exam whether this reaction is feasible or no, then you can give the answer with respect to both these points. Overall, I can say the elements like copper, mercury, silver, gold, platinum. These elements, they have their E naught positive, or I will say they are less reactive than hydrogen, and therefore these elements do not release hydrogen gas when they are treated with dilute acid. We can call these elements as chapa elements: copper, mercury, silver, platinum, gold. The last application is electrochemical series is used to find out whether a given metal will be able to displace another metal from its aqueous salt solution or no. For this you have to remember one very basic concept. The element with low E naught value or lower SRP will displace the element with higher SRP value or with higher E naught. For example, let us consider the reaction lithium plus ZnSO4. Whether lithium will be able to displace zinc from its aqueous salt solution, or in other words, whether lithium will be able to react with ZnSO4. For that, I need to consider the E naught values of lithium and zinc. The E naught value of lithium is minus 3.05 volt and that of zinc is minus 0.76 volt. So lithium has lower SRP value as compared to zinc, and therefore lithium will be able to displace zinc from its aqueous salt solution. Let us have one more example. Zn plus MgSO4. Whether zinc will be able to displace magnesium from its aqueous salt solution, or whether the zinc will be able to reduce magnesium, because if this reaction take place, it will be ZnSO4 plus magnesium. Magnesium in plus 2 oxidation state will get converted to 0. Zinc in 0 oxidation state will get converted to plus 2. Whether the reaction is possible, whether this displacement will take place or no, for that we will consider the E naught values. E naught value of zinc is minus 0.76 volt and that of magnesium is minus 2.36 volt. Now magnesium has lower E naught value as compared to zinc, and therefore zinc will not be able to displace magnesium from its aqueous salt solution. So using all these concepts, using the values of SRP, we will be able to find out whether the given reaction is possible, whether the given metal will be able to displace another metal, or whether acid on reacting with that particular metal will release hydrogen gas or no. So let us solve some questions based on this. This question was asked in JEE. The SRP values of different elements are given and you are supposed to arrange them in decreasing reducing power. That means you are supposed to identify the strongest reducing agent. We know low the value of SRP, better it will be reducing agent. So from the given data, we can easily see that Y element has lowest SRP value and therefore it will be the strongest reducing agent. And then comes Z with its SRP value minus 1.18 volt, and lastly it is X which has its value 0.52 volt. So likewise we can solve the questions. In the next question, we are supposed to find the strongest oxidizing agent. This is also your JEE question. This was asked in year 2017. We know higher the value of SRP, then it is good oxidizing agent. Now let us find out here. Chromium, here it is from plus 3 oxidation state, it is getting converted to 0. In the second example, from plus 6 oxidation state, it is getting converted to plus 3. In the third example, manganese is in plus 7 oxidation state. From it will go to plus 2. And in the last one, chlorine in 0 oxidation state goes to minus 1 oxidation state. So if I compare the given data, I find that MnO4 minus, when it is getting reduced to plus 2, it has highest SRP value 1.51, and therefore MnO4 minus is the best oxidizing agent from the given elements. So this is how you are supposed to use the concepts of SRP to solve the questions. Based on today's module, there are certain assignment questions for you people. To solve these questions, use the concepts of SRPs. Remember, you are not supposed to learn these values. You are not supposed to learn whole electrochemical series, as the E0 values will be already mentioned in your questions. So, using the concepts of SRP, you can easily solve these questions. That's all for the day. Thanks for watching. Have a nice day.